this episode, we're going to take the mystery out of validating e-commerce and web payments, because online payments can look simple on the surface while hiding a lot of moving parts underneath. When a customer clicks a button and a transaction goes through, several systems may be involved, including web pages, application services, third-party payment services, and back-end databases. New learners often assume the only thing that matters is whether the checkout page uses encryption, but the real risk is usually in everything around that moment, like how data is collected, where it travels, and what gets stored or logged. Validation without surprises means you can explain the payment flow clearly, show where cardholder data does and does not exist, and demonstrate that controls match reality rather than assumptions. A qualified security assessor, QSA, mindset is helpful here, even for beginners, because it pushes you to replace vague statements with evidence. Once you can see the whole payment picture, the rest of the work becomes far more predictable. Before we continue, a quick note. This audio course is a companion to our Course Companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A strong foundation starts with understanding what an e-commerce payment flow actually is, because different designs create very different security responsibilities. Some organizations build a checkout that collects payment details directly on their own site and sends them to their own server before forwarding them elsewhere. Other organizations use a design where the customer is redirected to a payment service page, meaning the merchant site never directly handles the full card number. There are also embedded payment approaches where a payment field appears on the merchant page but is actually controlled by a payment provider, so the sensitive input is sent straight to the provider without passing through the merchant server. These differences matter because they change where cardholder data can exist and which systems must be protected under Payment Card Industry Data Security Standard, PCI DSS. Beginners often think validation is a single yes or no verdict, but in reality, validation starts by identifying which design is in use and what that design implies. If you misread the design, everything that follows becomes a surprise later. Once you can name the design, the next step is building a clear data flow story that matches how the system truly behaves. Data flow is simply a description of where the customer's payment information enters, where it travels, where it is processed, and where it ends up afterward. In a web payment environment, this includes the customer's browser, the web application, any intermediate services, and any third parties involved in authorization and settlement. It also includes the less obvious places, such as logs, analytics, error tracking, customer support tools, and data exports used for reconciliation. A beginner mistake is focusing only on the main transaction path and forgetting the shadow paths created by troubleshooting and reporting. Validation without surprises depends on making those shadow paths visible, because that is where unexpected cardholder data often appears. When the data flow is accurate, you can align controls to it with confidence rather than guessing. A major source of surprises in e-commerce validation is misunderstanding what happens in the customer's browser, because the browser is an active part of the payment system. Modern checkout pages often load scripts from multiple sources, such as payment widgets, analytics tools, customer chat features, tag managers, and fraud detection services. Those scripts can influence what data is captured, where it is sent, and whether it is exposed to unintended parties. A beginner might assume the merchant controls the page fully, but web pages are often assembled at runtime from many components, and that creates real risk. Validation should account for how scripts are managed, whether changes are controlled, and whether the checkout page is protected against unauthorized modification. The core concern is simple. If an attacker can alter what runs in the browser, they can potentially capture payment data before it is protected by downstream controls. A careful, evidence-based view of the browser experience reduces unpleasant surprises during assessment. Another frequent surprise comes from the idea that encryption alone guarantees safety, when encryption is only one layer in a larger story. Transport Layer Security, TLS, protects data while it is moving between endpoints, but it does not prevent data from being captured at the endpoint itself. If the payment information is typed into a field controlled by the merchant site and then transmitted to the merchant server, The merchant server may see the data in clear form as part of normal processing. If malware, weak access control, or insecure logging exists on that server, encryption in transit does not stop exposure. Validation means confirming that encryption is used appropriately, but also confirming that the endpoints receiving data are designed and managed to be trustworthy. Beginners often want a simple checklist, but the better habit is to ask what systems can view sensitive data at any point, and what proves those systems are controlled. When you validate this way, encryption becomes part of a coherent design instead of a comforting label. Third-party services can reduce surprises or create them, depending on how clearly responsibilities are defined and implemented. Many merchants rely on payment processors, gateways, and hosted payment pages, and those services can reduce the merchant's exposure to cardholder data when used correctly. However, using a third party does not automatically eliminate the merchant's responsibilities, because the merchant still controls parts of the customer experience and may still handle sensitive data indirectly. For example, a merchant might store tokens, store transaction identifiers, or manage customer accounts that can trigger payments. The merchant also remains responsible for ensuring that integrations are secure, access to dashboards is controlled, and changes to payment configurations are governed. Validation without surprises means you can show where the third party begins and ends, and you can demonstrate that the merchant environment is not accidentally capturing full payment data through logs, form posts, or debug tools. Clear boundaries are comforting only when they are real. A particularly common surprise in web payments is accidental storage of sensitive data, especially in places that were never intended to store it. Web applications can log request bodies, error stacks, or form inputs, and those logs can be shipped to monitoring services where many people have access. Developers can capture full values during troubleshooting and forget to remove that behavior after the crisis ends. Customer support workflows can encourage copying and pasting details into tickets, notes, or chat transcripts. Backups can preserve older versions of data long after the main system is cleaned up. Validation requires looking for these accidental storage patterns and proving that they are prevented or detected. Beginners sometimes think storage is only the database, but in web systems, storage happens anywhere data is written to disk or retained in a service. Eliminating surprises means treating every data handling feature as a possible storage mechanism. Authentication and session handling can also create surprises in e-commerce validation because customer and administrator identities often share the same application ecosystem. Customers authenticate to view orders, manage accounts, and perform purchases, while staff authenticate to manage refunds, view reports, and administer settings. If authentication is weak for administrative areas, an attacker can gain access to capabilities that expose sensitive payment-related information or enable fraud. Even if the merchant does not store full card numbers, administrative access can still allow attackers to alter payment destinations, change integration keys, or modify scripts on checkout pages. Validation should confirm that privileged access is tightly controlled, that sessions expire appropriately, and that account recovery is not an easy bypass. A beginner misunderstanding is believing that because customers log in safely, administrators must be safe too, but the risks are different and often higher for administrative functions. Strong identity controls help prevent validation surprises that show up as unauthorized access paths. Another area where surprises appear is in the use of application programming interface, API, calls between services, because service-to-service traffic can be easy to overlook. E-commerce systems often rely on separate services for inventory, pricing, order management, fraud checks, and notifications, and these services exchange data continuously. If payment-related data is included in internal messages or events, it may traverse networks and be stored in message queues, caches, or logs. Validation means understanding what data elements are included in those internal calls and verifying that sensitive values are not being passed around unnecessarily. It also means confirming that service identities are managed carefully, because a compromised service account can become an attacker's bridge into sensitive functions. Beginners often assume internal traffic is safe because it is inside the company, but internal systems are frequently where attackers move once they gain a foothold. Removing surprises requires treating internal integrations as first-class security surfaces. Web application security controls deserve attention here, but only in the sense of what must be true, not as a product discussion. E-commerce sites face common attacks like injection, cross-site scripting, request forgery, and broken access control, and any of these can lead to data exposure or transaction manipulation. Validation without surprises means you can show that the organization has a secure software lifecycle, tests changes appropriately, and fixes vulnerabilities in a timely way. It also means confirming that the checkout and account areas do not reveal sensitive information through error messages or debugging features. Some organizations add a web application firewall, WAF, as a protective layer, and that can help reduce risk, but it is not a substitute for secure development and correct configuration. Beginners sometimes think a protective layer removes the need for careful coding, but layered defenses work best when each layer is treated seriously. The goal is to show that the application is designed and maintained to resist predictable web threats. Content delivery and hosting choices can produce surprises because modern e-commerce often relies on distributed infrastructure. A content delivery network, CDN, may cache pages and assets, and that caching must be managed carefully so sensitive content is not stored inappropriately. Hosting models may involve containers, managed services, or third-party platforms, each with different control points and logging practices. Validation means confirming that sensitive data is not cached where it should not be, that administrative interfaces are not exposed publicly, and that configuration changes are governed. It also means understanding how secrets like integration keys are stored and accessed, because leaked keys can allow attackers to impersonate a merchant or redirect payments. Beginners may assume infrastructure choices are purely performance decisions, but they influence security boundaries and visibility. When you validate hosting and delivery components thoughtfully, you prevent surprises that come from hidden caching behavior, unexpected public exposure, or unclear responsibility for security maintenance. Monitoring and detection play a crucial role in preventing surprises because they reveal whether the environment behaves as expected over time. E-commerce systems are dynamic, with frequent deployments, frequent marketing changes, and frequent third-party script updates, so yesterday's validation is not a guarantee for tomorrow. Good monitoring helps detect unusual changes to checkout pages, unexpected outbound connections, sudden spikes in failed logins, and anomalous administrative activity. It also helps detect attempts to inject malicious scripts or to exploit vulnerabilities in real time. Validation includes confirming that relevant events are logged, that alerts are actionable, and that there is a process to respond quickly. Beginners sometimes see monitoring as optional, but in web payments it is often the difference between a short-lived issue and a long-lasting breach. If you can detect changes and respond quickly, surprises become small and manageable rather than large and painful. Testing and evidence are what ultimately separate a calm validation process from a chaotic one. Testing includes vulnerability assessment, application testing, segmentation checks where applicable, and validation that critical controls like encryption and access restrictions operate as intended. Evidence includes records of change management, results of testing, documentation of data flows, and proof that sensitive data is not stored where it should not be. A key beginner lesson is that the strongest programs do not rely on verbal assurances, because verbal assurances collapse under detailed questions. Instead, they build a habit of producing artifacts that reflect reality, such as diagrams that match network behavior and logs that demonstrate control effectiveness. This approach also helps teams internally, because it reduces confusion and accelerates troubleshooting when problems appear. Validation without surprises is essentially the result of ongoing clarity, where the environment is understood well enough that assessment questions are answered with calm evidence rather than frantic discovery. As you bring all of these ideas together, validating e-commerce and web payments without surprises becomes a repeatable method for reducing uncertainty in a complex, fast-moving environment. You start by identifying the payment design and making sure the claimed model matches what actually happens in the browser and on the server. You build an accurate data flow story that includes third parties, internal services, and the shadow paths created by logs, exports, and support workflows. You confirm encryption is end-to-end where needed, while also confirming endpoints are controlled because encryption does not protect you from compromised endpoints. You verify identity controls and administrative access because attackers often target privileged functions and integration settings. You evaluate application security and infrastructure behavior so web threats, caching, and hosting choices do not create hidden exposure. You support everything with monitoring and regular testing so changes do not quietly undermine protections. When you validate this way, surprises become rare, and when they do appear, they are contained quickly because the environment is built around visibility and disciplined control.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.